Here we have a SAT math question. So there is a system of two equations over here. In the given system of equations, k and m are constants. The system has a solution of 2 comma y. What is the value of k? Okay, in the given system, we have to find the value of k. And also the question says the system has a solution of 2 comma y. Since 2 comma y is a solution for the given system, we can plug in this x coordinate 2 for the x in each equation and y coordinate y for this y in each equation. Okay, first let me plug in this x coordinate 2 for x in each equation. Okay, so we have 7k times 2 positive 13 times m, and I'm going to plug in this y coordinate y for the y in each equation, I mean in the first equation. So if I plug in y for y, again I'm getting the same thing, that is 13 times m times y equals to 20.5. Okay, so when I simplify this one, that is 7 times 2 is 14, 14 times k is 14k, positive 13 my equals to 20.5. I consider this is equation number 1. Okay, now I'm going to plug in the x coordinate and y coordinate in the given solution for x and y in the second equation. So first let me plug in the x coordinate 2 in the solution into the second equation for x. So let me do it. That is 6 times k times 2 positive 5 times m times. So when I plug in y for this y, I'm getting the same thing, 5 my equals to negative 48. Okay, let me simplify. So 6 times 2 is 12k positive 5 my equals to negative 48. Okay, I assume this is equation number 2. Okay, now in this system, I have to solve for k, that is, I have to find the value of k. So for that, I have to get rid of the terms which contain my in these two equations. That is, I have to get rid of 13 my and 5 my. So that is, I have to eliminate the term which contains my. So how can I do it? So first, let me look at the coefficient of my in the first equation, that is 13. The second equation is 5. So our first work is to eliminate the term which contains my. My first work is to get the same coefficient for the term which contains my. Okay, so for that I find the least common multiple of this 13 and 5, that is 65. Okay, so first let me multiply the first equation by 5. So when I multiply the first equation by 5 and particularly when I multiply this 13 my by 5, I'm getting 65. So 65 is the least common multiple of these two equations. Okay, let me multiply the first equation by 5. When I multiply this 14k by 5, I'm getting 70k, and when I multiply this positive 13 my by 5, I'm getting positive 65 my, and on the right side when I multiply this 20 0.5 by 5, I'm getting 102.5. Okay, now I'm going to multiply the second equation by negative 13. So why should I multiply the second equation by negative 13? Actually, my aim is to get coefficient 65 for this my, because I need to get the same coefficient for both. For the term which contains my in both the equations. Okay, because that's the least common multiple of 13 and 5. And here we have positive sign. If I multiply the second equation by negative 13, it will become negative 65 my. Already we got positive 65 my. Once I get negative 65 my in the second equation, I'll be able to eliminate the term which contains my. Okay, so I multiply the second equation by negative 13. Okay, when I multiply this one, second equation negative 13. So first I multiply this positive 12k by negative 13. When I multiply this 12k by negative 13, I'm getting negative 156k. When I multiply this positive 5 my by negative 13, I'm getting negative 65 my. And on the right side, when I multiply this negative 48 by this negative 13, I am getting positive 624. Okay, now let's simplify. So this positive 65 my and negative 65 my will cancel out. So when I combine 70k negative 156k, I am getting negative 86k. On the right side, when I combine positive 102.5, positive 624, I am getting positive 726.5. Okay, let me take the equation over here. Now I have 86k equals to 726.5. Okay, since I want to solve for k, I have to get rid of the negative 86, which is multiplied by k. For that, I divide both sides by negative 86. When I do so, this negative 86 will cancel out. I'm just getting k on the left side. On the right side, I have negative sign over here. I'm taking this negative sign as it is. And when I divide this 726 by 726.5 by 86, I'm getting 8.447, and it keeps going. So when I round this value to the nearest hundredth, I'm getting negative 8.45. Since I round this one to the nearest hundredth, I consider the digit at the thousandth place. So since it is greater than 5, I just simply all the digits to the 7 and to the right of 7, and I just add 1 to the digit at the hundredth place. So the approximate value of k in the given system is negative 8.45.